Hello and welcome to all students. In this lecture, we study about theorems on limit. In previous lecture, we saw the uniqueness theorem on limit. Okay, so let us see the next theorem. Next theorem is a sandwich theorem, and further we see the limit of a composite functions. Theorem on limit of a composite function. Okay, so let us go to. Okay, so this is sandwich theorem. Let I be an interval having the point A as a limit point. Let G, F and H be functions defined on I, except possibly at A itself. Suppose that for every x in I not equal to A, we have f of x greater equal g of x less equal h of x, and also suppose that limit of g of x extends to a is equal to limit of h of x extends to a is equal to L. Then limit of f of x extends to a is equal to L. So this is sandwich theorem. The proof of this theorem, let us see the proof now. Okay, so statement is already stated. Now go to the direct proof of this theorem. Given that function f of x is greater equal g of x and less equal h of x for all x belongs to I. Also given that limit of g of x extends to a is equal to limit of h of x extends to a is equal to L. We show that limit of function f of x extends to a is equal to L. So from given, for any given epsilon greater than 0, there exist delta 1 greater than 0 whenever mod of x minus a is greater than 0 less than delta 1, and this implies that mod of g of x minus L is less than epsilon. Also for same epsilon greater than 0, there exists delta 2 greater than 0 whenever mod of x minus a is greater than 0 less than delta 2, and this implies that mod of h of x minus L is less than epsilon. So this is I have written from the definition of limit of a function. Now choose delta is equal to minimum of delta 1 and delta 2. So for this delta, whenever mod of x minus a is greater than 0 less than delta, both inequalities will true. First is mod of g of x minus L is less than epsilon and mod of h of x minus L is less than epsilon. So we have f of x is greater equal g of x less equal h of x, and it is true for all x belongs to I. Subtracting L from each term, then we get g of x minus L is less than or equal to f of x minus L less equal h of x minus L less than epsilon. And from this inequality, we can write we can write f of x is greater than minus epsilon, f of x minus L is greater than minus epsilon less than epsilon, that is mod of f of x minus L is less than epsilon. Thus for given epsilon greater than 0, there exists delta greater than 0 whenever mod of x minus A is greater than 0 less than delta. This implies that mod of f of x minus L is less than epsilon. That is, whenever distance between x and a is greater than 0 less than delta, this implies that distance between f of x and L is less than epsilon. That is, whenever x approaches to a, values of f of x approaches to L. This means that limit of function f of x extends to a is equal to L. So this is the end of this. This is the end of this theorem. Now let us go to the next theorem, limit of a composite function. Limit of a composite function. Theorem states that if f and g are functions such that limit of g of x extends to c is equal to L and limit of f of x extends to L is equal to f of L, then limit of f of g of x extends to c is equal to f of limit of g of x extends to c, or we can say that it is equal to f of L. The proof of this theorem is okay. So limit of composite function statement is already stated. If f and g are functions such that limit of g of x extends to c is equal to L and limit of f of x extends to L is equal to f of L, then limit of f of g of x extends to c is equal to f of limit g of x extends to c, or we can say that it is equal to f of L. We show that for any given epsilon greater than 0, there exists a delta greater than 0 whenever mod of x minus c is greater than 0, less than delta. This must implies mod of f of x, f of g of x minus f of L is less than epsilon. For given epsilon greater than 0, there exists delta 1 greater than 0 whenever distance between u and L is greater than 0, less than delta 1. This must implies f of u minus f of L is less than epsilon. Also from given there exists delta 2. For given delta 1 greater than 0, there exists delta greater than 0 whenever distance between x and c is greater than 0, less than delta. This must imply distance between g of x and L is less than delta 1. Put u equal to g of x. So whenever mod of x minus c is greater than 0, less than delta, this implies that mod of g of x minus L less than delta 1, and this implies that mod of f of g of x minus f of L is less than epsilon. This shows that limit of f of g of x extends to c is equal to f of limit g of x extends to c is equal to f of L. And this is the end of theorem on composite function. So this okay. So thank you for paying attention. Thank you very much.